Welcome to this episode of Code and Creativity, where we dive deep into the fascinating world of programming languages and explore innovative ideas that push the boundaries of what's possible in coding. Today, we're venturing into a rather intriguing hybrid of languages, C++ Prolog, or C+P for short. Now imagine a world where two of the most significant programming languages, C and Prolog, have a baby. Sounds interesting, right? C, known for its performance and near-universal application, and Prolog, a venerable ally in logic programming. Despite their strengths, they've coexisted for decades with a notable tension over which is superior. So what happens when you combine them? C++ Prolog is presented as a playful attempt to merge the best of both worlds. Here's a fascinating tidbit. While many have tried to make C resemble Prolog or vice versa, C+P employs a new approach entirely, by directly adding features from both languages. It translates Prolog syntax into C code, allowing developers to leverage the strengths of Prolog, like logical expressions and rule-based structures, all within the familiar C environment. You might be asking, how does that even work? Let's break it down. At its core, C+P uses Prolog terms, turning them into valid C code. For example, instead of your standard C main function, you might see a Prolog twist. Prolog int func main puts hello world, return 0. Your initial reaction might be, wait, is that even C? Well, it is a bit of an odd version, but what's happening here is quite mind-bending. This quirky syntax, while throwing some counters to conventional C, demonstrates how you can read it as a list of terms through Prolog. So we have an entirely new way to write programs that, when compiled, produce efficient C code. Let's take a moment to talk about one of the standout features of C++ Prolog, the stet equals operator. This operator does some fascinating things under the hood, allowing for macro-like functionalities within the code. You define your functions using this operator, which automatically handles some logical evaluations. It's like having a mini preprocessor that ensures your code is concise and efficient, steering clear of the traditional pitfalls of operator precedence issues. Imagine you're working on a project and you need to compute the maximum of two numbers. Instead of manually handling comparisons every time, you could write something like this: Prolog max a b equals ab, then a else b. This way, the C++ compiler will seamlessly convert it into a succinct C function call. Pretty neat, right? Now let's touch on generics. In traditional languages, generics allow for types to be flexible and reusable. C++ introduces poor man's generics, where you can define a generic list and specify the type when you instantiate it. This method preserves the clarity of namespaces, ensuring your types remain organized while also pushing the limits of what C-based systems can do. But as intriguing as C++ sounds, it's not without its quirks. For instance, it relies heavily on macros, which can create a barrier for new users. There's also a degree of complexity in validation. If you're not careful in your syntax, you could end up with broken C code or silent failures, which is every programmer's nightmare. So why would someone consider using C++ Prolog? Well, it allows you to access the robust performance of C while exploring Prolog's logical capabilities. It opens a dialogue on macro systems versus traditional programming paradigms. But here's a little food for thought. Does this method of blending languages truly improve the development experience, or does it add unnecessary complication? Before we wrap up, let's ponder over the larger implications. C++ Prolog stands as a compelling exploration of programming language design and the creative possibilities that emerge at their intersection. Whether or not it becomes a mainstream solution